Welcome back. In our earlier classes, we have already learned the basic concept of all the logic gates. We have learned to represent all other logic gates by using universal gate like NOR and NAND gate. We have also learned different laws and rules of Boolean algebra and also De Morgan's laws, and we also simplified several Boolean expressions. In today's class, we will learn quickly two important terminologies in digital electronics such as Minterm and Maxterm. So let's get started. First, we will start with Minterm. The functionality of a digital circuit is represented by a logical function, and these logical functions are generally expressed in terms of logical variables. In Boolean algebra, we have seen that Boolean variables, which are logical variables, these logical variables or logical functions, they accept data in binary form. Now, the minterm. Minterm is a product term in a logical function containing all the variables of that function in either original or complemented form. These logical variables mostly are inputs to that digital circuit whose functionality is represented by logical function. Now these logical variables can be either in original form or in complemented form, and there could be many combinations among those variables. So the product containing all these variables, whether it is in original form or complemented form, that is called minterm, and there could be many minterms depending on how many logical variables we are using for that function or for that logical circuit. Now here we are using the term product. By product, we know in Boolean algebra or in logical circuit is the AND operation between all the variables of that function. Now suppose if in that logical circuit, if we have two variables or maybe two inputs, say A and B, then we know as these logical variables accept only binary data, and binary data means it has only two values, either 0 or 1. So if we have two variables, then we will have four possible combinations: 0 0, then 0 1, 1 0, and 1 1. So that means if in that logical circuit or in that function, if we have two logical variables, then we will have four possible combinations. Similarly, if we have three variables in that logical function, then we will have 8 combinations. That means if we have two variables, then we have four possible combinations. So 4 means 2 to the power 2, and if we have three variables, then we have 8 possible combinations. That means 2 raised to the power 3. So if we have k variables, then we will have 2 to the power k number of possible combinations. Now here we can see a table where we have used three logical variables a, b, c, and we know there is 8 possible combinations among these three logical variables. Now minterm in the logical circuit or logical function is represented by small m, and which minterm we are referring, that is represented by m and a suffix number, which is actually the decimal equivalent of that binary combination. So if it is 0 0 0, then we know that the decimal equivalent of that combination is 0, and the last combination, which is 1 1 1, that we know that the decimal equivalent of that binary combination is 7. So this is the way how we represent minterm in the logical function. Now we will learn that how we will represent those combination in that function. So the rule is, if in the minterm a variable appears in the original form, then it possesses value 1 in the corresponding combination. Or on the other hand, we can say if a variable possesses value 1, that means in the function, in the minterm, it will be in its original form. So as we can see, the last combination, in the last combination we have 1 1 1. All the logical variables, they have 1. That means, as we know, in case of minterm, 1 means the original form. So here the minterm will be a, b, and c, or we can say that the AND operation between all these logical variables a, b, c. And the other rule is, in the minterm, a variable appears in the complemented form if it possesses value 0 in the corresponding combination. That means, again we can say on the other hand, if the variable possesses value 0, then in the minterm it will be in complemented form. So here, as in the first combination, as we can see, all the logical variables have 0. That means in the minterm their combination will be, it will be in complemented form. So it will be A complement and B complement and C complement. That means we will have AND operation between all these complemented value of all these logical variables A, B, C. So this combination will be what? Since A, B, they have 0 and C is 1, so it will be A complement, then B complement, then C. Then the next combination is 0, 1, 0. That means A will be in complemented form, B will be in original form, and C will be again in complemented form. Likewise, it is 0, 1, 1. So it will be A complement, then B, then C, original form. Then it is 1, 0, 0. So it will be A, then B complement, then C complement. Next, it will be A, then B complement, then C. Then it will be A, B, and then C complement. So these are the 8 possible minterms in case of 3 logical variables. Now for a k variable function which has 2 to the power k minterms, for any input combination, one minterm will have value 1 while the remaining terms will have value 0. Suppose if we choose this combination. So this combination means what? 1, 0, 0. So 1, and the minterm is what? A, B complement, C complement. So A has 1, so its value will be 1. B complement, actually B has 0. So complemented value, complemented B will have 1. And then the C, original value is 0. So complement of C will have 1. That means the product or the AND operation between this A, B complement and C complement will have value 1. Now if we check all other remaining minterms, they will give us 0 value. Now suppose if we choose this combination A complement, B complement and C, and what are the values? 1, 0, 0. Now if we put these values in this minterm, what will be the value? A complement. A complement means what? Actually the value of A is 1, so A complement means 0. B complement is 1, 0, and complement of 0 is 1, and C is 0. So that means in this minterm what we can see is the complement of A has value 0 and also C has value 0. So when we will perform AND operation for this minterm, the value of that minterm will be 0. Now if we choose arbitrarily some other combination like this one, then what will be the value? A, B, C complement. And what is the original value? 1, 0, 0. So it will be 1, this will be 0, and this will be 1. So A and C complement, they have value 1, but since B is 0, B has the value 0, that means the AND operation between A, B and C complement, again it will give us 0. That means for any particular set of value, only one minterm will give us value 1 and all other remaining minterms will give 0 value. And that is true for any set of value for that k variable function. Now we will learn about maxterm, which is similar to minterm, but there are few differences. What are the differences? In case of maxterm, it is a sum term instead of product term. Now it is a sum term in a logical function containing again all the variables of that function in either original or complemented form. So again all the variables in that logical function will be there. It is a combination of all those variables and it will be either in original form or in complemented form, but this time it is a sum term, and by sum we understand it is basically a OR operation between all the variables of that function. So in Boolean algebra, by product we understand AND operation, and by OR we understand sum operation. And again the similarity, if it is a 2 variable function, then we will have 4 possible combinations. If it is 3 variable function, then we will have 8 possible combinations. That means if we generalize, and if it is a k variable function, then we will have 2 raised to the power k possible combinations. And max term also we will try to understand what could be the max terms for a k variable function. And this time also we have taken a 3 variable function, and 3 variable means we will have 8 possible combinations. That has already been written here. And another difference is the max term is represented by capital M, and again capital M and the corresponding combination is represented by the suffix number, and this time also suffix number is the equivalent decimal number. So if it is the first combination, then the equivalent decimal number will be 0, so it will be capital M then suffix 0. And if it is the last combination for 3 variable function, then the last one means the decimal equivalent will be 7. That's why for 111 binary combination, the max term is represented by capital M suffix 7. Now, how the max terms look like? In case of max term, again there is a difference. In the max term, a variable appears in original form if it possesses value 0 in the corresponding combination, and a variable appears in complemented form if it possesses value 1 in the corresponding combination. In case of min term, the scenario was opposite. So in case of max term, what is the rule? If a variable appears in original form, then it possesses value 0. That means we can say, on the other hand, if the variable possesses value 0, then it will be in the original form. So here in the first combination, as we can see, for all the logical variables, their values are 0, 0, 0. And since it is max term, so we will have OR operation between all the logical variables. So this time it will be A plus means OR, then plus C. Similarly, for the last combination, when the combination is 1, 1, 1, then it will be, what is the rule? The rule is a variable appears in complemented form if it possesses value 1 in the corresponding combination. That means we can say, if it possesses value 1, then it will be in complemented form. Now in this combination, all the variables have 1. So it will be A complement, then plus B complement, then plus C complement, and their total value will be 0 in case of max term. So if it is 1, 1, 1, then it will be 0 plus 0 plus 0. So it is a OR operation between all the variables which have 0 value. So the final output of that operation will be 0. Similarly, now if we fill for all other max terms, then 0, 0, 1, it will be A plus B, then this time it will be C complement, and then this one will be A complement plus B complement plus C. And you can check here that all the combinations are different from each other. And again, like min term, if we choose any input combination, then we will see that for that particular input combination, only one max term will give you value 0, this time 0 since max term, and all the remaining max term will give you value 1. So now if we check this one, 0, 1, 1, so this will be 0, then this will be complement of 1, so 0, and this will be complement of 1, so 0. And we are performing OR operation between 3 zeros, so finally the output will be 0, and that's what we want. And if we check for this input combination, all other max terms, like if we check this one, so 0, 1, 1, these are the values, so it will be 0, but this one will be 1, and this one will be complement of 1 means 0. So 0 and 0, these two are okay, but since B is 1, that means if we perform OR operation, then the output of this OR operation will be 1. Now if we choose any other max term like this one, so 0, 1, 1, complement of A, complement of 0, this one will be 1, this one will be 1, and this one will be complement of 1, 0. So this one 0 is okay, but other two variables will have 1. So finally the output of this operation will be 1. So this is true for any input combination of a k variable function. I have verified 3 of them. Now you can verify for the remaining 5 max terms. So this class was about 2 important terminologies of logical function. In our next class, we will learn about 2 more important terminologies or concepts of digital electronics, such as sum of product and product of sum. Till then, stay safe and stay healthy. Thank you.